So, good afternoon or good evening, everybody. Welcome to this 44th meeting of the Network Management Research Group. Before we start, as usual, do we have any person volunteering to take notes? That person will be much appreciated. So for the guys that just entered into the room, we were looking for people that would be willing to take notes. Nobody? Come on, people, we need some help here. Newcomers would like to take notes. I can translate it too. Would you be willing to? Let me see if there is anybody else that could help. For those entering to the room, we are looking for note takers. Anyone? Okay, so we have one, and I'll try to do that too. So this is the usual note well. Today we're gonna have a very short meeting. This is actually the second slot that we have on the week, because we have the first slot on Monday, which was actually a workshop, which is part of a series of workshops that we have on network measurements and monitoring. This second slot is expected to be much more informal. We will have today 3 presentations, but we'll have some minutes at the end of it to talk about the research group itself and future directions, and occasionally informal announcements. In these last minutes, I expect to move on with the discussions we have already started this year in Lisbon during IM 2017, and Alex was there, Roberto was there. So I wanted to take this part of the meeting to talk about administrative things and future aspects, including drafts. Is that the question that you'd like to ask, Alex?
I had one question actually. There was one we had at the last Nmrg meeting in Lisbon.
Yes.
There was a discussion that we started concerning intent versus policy-based management and so forth, and whether we needed to have a discussion regarding this distinction on that. And I was wondering if you wanted to add that to the agenda.
Yes, at the end of it. That's the discussion part of it. I wanted to resume the discussion that we have on Lisbon in that part of the meeting.
Okay.
So it's already there.
Oh, okay, all right. Okay.
So the other presentations that we have, first one is by Insu Kim, and then we have Klaus talking about his work on SDN, and then Angela will talk also about management, autonomic management in SDN. And then that we follow with that discussion I just mentioned before, okay? So let's move on for the first presentation. Minsu, please. This is, what's the slide? Yes. Just a second. Yeah.
Hi, my name is Minsu Kim from ATRI. I'm going to present our drafted for the intelligent management using the collaborative reinforcement multi-agent system. So we have another authors whose name is Yonggun Hong from ATRI and Yeonhee Han from the Korea Tech. This is our depth overview. So if you wanna, I have only 10 minutes. So if you wanna check the more details, you can go over to the network management IG data tracker, so you can check everything all. We taking the one of the machine learning algorithm that is reinforcement learning. So I think reinforcement learning is really useful to manage it and monitoring some system intelligently. So reinforcement learning consists of 3 components. So first one is action, and state, and we can get some reward from the for the optimal value. And the policy is one of the important component for the reinforcement learning. So in the policy, we can evaluate some data from the action and state and reward value. This is page call and reinforcement diagram. So we have a general motivation for the reinforcement learning. So reinforcement learning is a system capable of the autonomous acquirement and incorporate of knowledge. So we can reinforcement learning can be applied to the network field for intelligent management in terms of the network monitoring system. So we believe the reinforcement learning can solve some network issues such as connectivity and traffic management and fast internet without latency extra. This is our proposal, our method, architecture overview. So we can we have made multi-agent that has agent in the distributed node that multi-agent can take action. Then the agent can make some result to the transfer to the global environment. The global environment means centralized node. Then after evaluation in the global environment, we can get the reward, the transfer to the multi-agent for the next available step. This is our simulation to compare with the normal process versus reinforcement learning process. So the left slide is normal process. It's really fluctuate, and right one is we can get a more optimized value. So first one is random exploration. So after randoms, we can make some optimized reward to get some reinforcement learning system. So this is a multi-agent reinforcement learning techniques. So the centralized node has a different node. Each node have some node train. The node train manage it and control hold some edges. So in this proposal, we took the distance and frequency schemas for the policy. And the next one is second proposal method. This one is sharing information. So the agent can take some actions. Then this one is transferred to the global environment. That was a centralized node via the node. And then after evaluation, the reward, the optimized values, the broadcast the whole everything. So for the next available step. So this is the second result for our scenario. So left is the sharing information. If we sharing information, we can get the more efficient results rather than the not sharing information. But in the right result, we can less result than the sharing information, but this one is still have a nice, great result for because we use the reinforcement learning. So we have possible network scenarios. So first one is an autonomous driving system. The autonomous driving system is a self-autonomous driving without human control. So we can set the optimized trust region policy. We also consider about the wireless sensor network because wireless sensor networks are already applied to many wides of the schemes, such as corporate communication, routing, and any other intelligent management and monitoring system. So last one is routing enhancement. I think we have a minute. So routers can determine the described optimal route with the predicted reward. So routing can reduce the overhead. So we can believe. So this is our ongoing work. So we set the environment. The environment consists of the routing protocol. Then the environment, each environment has controlled by the machine learning platform. So we are creating the machine learning platform, and this one provided the corporate machine learning algorithm. So we assume the agent is routers, and policy is a routing table. So we're gonna matching something to set the architecture to provide optimal path and reward, and we just ongoing and keep going to make some architecture for the reinforcement learning. So next step is we created adaptive intelligent networking management model with reinforcement learning, and we also set the reinforcement learning scenario, and then we also need to the pre-processing for the data set. So we it's a really hard to get some data set, real data set from the network field. So we just collecting and makes effort the real data, and then make some pre-processing. So my slide is that's it. So if you have questions and comments, let me know.
Some questions, one or two.
This is Jefferson Aubrey. My question is, I have two questions actually. The first one, it's I didn't understand if you are saying about the autonomous driving system, if you are referring to the automotive networking system, or is just using reinforcement learning for the whole thing, you know, like for the driving system.
Yeah, we considered the whole things, but first of all, we consider an autonomous network system using the reinforcement learning. Then if we got some real result from the autonomic our implementations, we also adapted this the whole network field. So that's why we just keep going and make some effort to the first. I think we need to take some first step to the intelligent management. So I think with this is first step. So we also consider about autonomous system. Yeah.
And the second question is about, because as you using reinforcement learning, I think that you have to define the utility function, and also you have to specify which are the data models that you're using to feed your system. So, for example, in the second and third use case, I'm wondering if you're using some IETF data model such as Yang or something, you know, in order to define how your network is organized and then configured for the performance of to perform the network management tasks.
My name is Yong-gun Ho, one of the authors of this thread. So I try to answer your question. So right now, we don't use our own data model, so not using the Yang or other model. So I believe that in future, it's more better adopt Yang model in this our proposed model. Thank you.
I think this is a cool work, so I hope that you continue in the Nmrg.
Thank you.
Just one comment. I remember that back in 2000, there were some papers on the network management community that were addressing the use of reinforcement learning for network management. and it would be interesting to have somehow a link that explains what's different now
Okay.
in comparison to what we have almost
2015?
2000.
2000, okay. So, okay, it's a really long time. So, okay, I see.
Don't tell anyone. Thanks.
Thank you.
Klaus.
Good evening, my name is Klaus. I'll talk about reference models for representation for SDN. And this talk is related to the draft that we recently uploaded. The time slot I have is short, about 10 minutes, so I only will be able to go to some main points of the work. If anybody has an interest to more details, I encourage you to read the draft, and even after that, contact us. So, well, SDN can become very complex. There's no news with this, so nothing here. And SDN are multi-layered structure. At least you have a layer for application, a layer for control, a layer for data. And if you can also have additional layers, if you go for hierarchical controllers, hierarchical applications, and so on. The point here is that a simple graph structure is not fully capable of representing this kind of network. Even some earlier representations for multi-layer networks have some issues in fully represent such a system, and permit that you have algorithms that are easy to obtain and reliable to work. For this, we present a graph generalization that we recently created, which is capable of represent multi-layer or even more complex networks. But we will restrain to only multi-layer at this point. This representation is capable of retaining the full information of the layered structure, and it is also capable of being equivalent to a directed graph. In that way, it is possible to use already known representations for the structure itself. It can be, for instance, represented by adjacency matrix or any other actually ways you can represent a directed graph. And in addition of that, the algorithms to be used with these representations are either exactly the same that you would use with directed graphs, or the base algorithm for a directed graph with minor interventions for specific results. We have two papers. The first one deals with the theoretical part of this work, and there it's a set of theorems that prove the properties we're claiming the subject to have. And the second one deals with algorithm representation of this kind of graph and the algorithms to work with them. So these are the full papers for explaining this object. And what we really propose in this draft is a special case of this, which is specifically done for multi-layer, just multi-layer. So it's a bit different representation, where we have a vertex set, an edge set, and a layer set. And the edges in this case will be represented as ordered quadruples, as here. And we will have initial a vertex, initial layer, destination vertex, and a destination layer. With this, we are able to maintain a property that's basic for graph, which is its property of resembling a binary relation. To do that, we see this edge actually as a pair of pairs, and then the binary relation is maintained between pairs. This makes that these objects has the same structure of a normal directed graph. Further, from this we can infer that there are different kinds of edges. We can have interlayer edges in which objects of different layers are being connected, but actually this is the same object in different layers. We can have intralayer edges, which connects objects in the same layer, here represented in blue. And finally, mixed edges, which can connect different objects in different layers. Here they're represented in green. And if we want to represent undirected edges, we do this by using two edges. Pretty much as we do when we represent undirected graph by a matrix, where we have two entries with ones to represent two edges. So it's pretty much the same case here. From this, we can also see that we can split the edge in two pairs and treat each pair as being a vertex of what will be a directed graph. So from this we can have exactly the structure of a normal directed graph. However, the additional information that is brought by the multi-layer part is directly encoded either in the vertices or in the edges. So even though we maintain the original structure of a graph, we have the full information of the layered structure. And we can then apply this to SDN models. Here it's a very small example of an SDN model, where we have an application layer, a control layer, and a data layer, and some connections between them. From this, we can start to see things that we would normally find in a network and also in its graph representation. As here we have a notion of paths. Here we have a path going from D2 data layer to D1 data layer, then from D1 data layer to D3 data layer, and so on. So this is a path fully built in the same layer. It's an intralayer path. We can have other forms of paths, like this in green, which connects the controller 1 at controller layer to the D2 at the data layer. And so this is a mixed edge and also a mixed path. Both these paths will reappear later in the color, so have to remember here that green is for mixed paths and blue is for intralayer. We can also have notions of shortest paths. Actually, with this we can reconstruct all the notions that are already known from the graph theory, which is a very extensive body of knowledge. And we can also have solution for some problems that we have in multi-layer regarding with projections of the paths. So here we have the matrix representation of exactly this small example that we presented initially. And we can see that this has a special block structure. This can be achieved, and we call this the canonical graph representation in adjacency matrix. So here, the main block diagonal represents only the intra-layer nets, and the other kinds of nets are in the off-diagonal blocks. We can see this here. The data intra-layer connections all appear in the upper left block. As we can see, it goes from data layer to data layer. And marked in green, we have that green edge that we saw between controller 1 and data 2. And this edge is represented here by 2 ones as we would do it in a normal graph. However, in the block that goes controller to data layer, and the other one in the block that goes data layer to controller. In this way, we can do the representation in matrix form. And the takeaway messages of this is that we can use this to represent SDN while retaining the full information of the layered structure. The representation we get is actually equivalent to a directed graph, and it can be then represented by matrices or any other form we can use for directed graphs. And much of the algorithms we already have and the full extent of graph theory can be directed applied to this object. And also the system itself, the whole SDN layer, can be represented by a single mathematical object, which is this specially created matrix. And thank you.
Thanks, Klaus. You mentioned that you already posted the last version on the mailing list, right? Yes. This is the 4th review?
From the left?
Yeah.
It's the first review.
It's the first, okay. Did you get any feedback on the mailing list?
Not yet.
Okay.
On my way
We
for
can
the
work.
feedback.
Okay.
Diego Lopez. A couple of questions. One is related to the matrix. You were mentioning the properties. Could you elaborate a little bit on which kind of properties you can verify when it comes to the network? Do you have in mind any kind of tool or something like that?
What you can do with the representation to obtain the results for the network. Well, you can represent it, you can calculate flows, you can calculate distances, you can do everything you would do with the net representation, for instance, inside of the controller. You could use this to represent the entire net.
So, and you're aware of tools that would help us in doing so? I mean, just because in the draft, making some reference to you can use this or that or that. I mean, what would be important for us, we have been working in the past in an environment that we could use an Eclipse environment to develop and to validate networks. Probably trying to integrate these two things would be really interesting.
Okay, you can do that, no problem. The basic algorithms you have for directed graphs will work in this environment. So only if you want some special kind of results where you only want to see one layer or you only want to see edges, then you have to do composition, actually projection of the edges, and then you just have to add this to the basic algorithm. So if you have an algorithm for something like flow, and you want to have the flow seen only in terms of vertices, you only have to add the part of the projection of the layers on the already known flow algorithm.
Okay, That's something I had to think a little bit about. Mostly when we're talking about, because that includes dynamic properties, right?
Yes.
You're mentioning flow. Yeah, that's something that's. Second thing is that how do you input data? I mean, because this is the matrix representation.
Yes.
Do you have any kind of language? Have you been using any language for programming, so to say, the thing, or it's?
Yes. The language we use to write the basic algorithms and publish them was actually Python.
No, I refer to when you're describing the network.
Oh, no. We are just bringing the idea to the network field now. So we could work to obtain this. If you have interest in that, we can further talk by email or some other way to achieve this.
Yeah, but I mean, the idea would be, and what I have in mind is precisely connecting with this environment I was mentioning. So
okay, yes.
yeah,
it is possible to do that, but
okay.
We have to consider the details of that.
No, sure.
And yeah, we could do
that's
this.
why I was asking whether you had made any tests or you have any preference or first results on from whatever the language. Just,
yeah, we have tests with these in greater scale with networks, but not in computer networks. We have this for transportation networks and other kinds of networks with hundreds of thousands of loads. So we can say this can scale to large networks, but the specifics for computer networks, the specifics for SDN, they still have to be built.
Diego, but try to summarize your suggestion in this case. Is including in the draft links to these previous efforts, like the Eclipse or the language?
No, not necessarily. What I was asking is if there could be some links about which are the tools. For those of us who are not familiar with the graph theory, it's about to say you can use X, Y, or Z for this, and that. Mm-hmm. And suggesting some hints on how a language could be used as input for building the matrix would be helpful as well.
Okay. Mm-hmm. Thanks.
Okay.
Let's move on for the next one. Angela, please.
Okay, hello everyone. This is Angela Rodriguez from University of Cauca in Colombia. I'm going to present my PhD proposal, no draft, not still, just PhD proposal, which is titled Framework for Autonomic Management in Software-Defined Networks. So here's the outline, and I will skip through introduction. So my context area is also software-defined networks. So just in a phrase, software-defined networks is the coupling control task from the forwarding devices. Okay. However, when the SDN was first stated, the management was not taken into account. Some projects just try to put some paths here in the application plane to perform management task. Others just put it in the control plane, like for kind of mixing of controlling and management functions. Recently, some proposals from ONF, E2, and other authors has stated a vertical management plane. So why is necessary a vertical management plane in SDN? Well, just because each plane of the SDN needs to be managed. For example, here we have forwarding devices. The initial setting up of these devices, it's a management task. Here we have controllers. Controllers have a critical role because they have to perform most of their tasks in real-time regime. So monitoring the controller's status and any abnormal behavior is a management task. At the application plane, we have to manage also for example, the service level agreement / contracts, all that stuff has to be managed. So that's why vertical management plane is necessary. Well, we are aware that Nmrg has an RFC where they stated management plane at the same level of the control plane, okay? But they, in this RFC, management plane has no a direct communication with the control plane. So that's why we decided to use this one. On the other hand, I have the autonomic network management paradigm. So what that's for, ANM. The main goal is to reduce human intervention during management operations. So how can this be achieved? Well, we need that the network, the system, or in this case, the network can be able to be aware of context change and adapt to those changes. So we have a MAPK model, like you see here, that is like coordinated with some autonomic control loops and decision elements to perform adaptation to context change. Okay, so we have some components, as you see here: monitoring, analyzing, planning, executing, that form a closed control loop. Well, in autonomic network management, a human administrator will still remain, but with the role of defining only high-level objectives, high-level policies. All of these, the idea is that a system achieves self-features, okay? All of these, almost all these issues are currently being working at IETF ANIMA working group. Well, like a motivation, I put on board a open flow specification. So what's that? We have a controller that defines or that fills the forwarding tables that I finally implemented at network devices based on OpenFlow. So let's suppose that we have a SDN network with some OpenFlow-based devices. And let's suppose one of those devices has failed. And of course, some of the forwarding paths will be no longer available. So SDN has two methods to solve this situation. First one is restoration. How does it work? So in restoration, the controller will refill all the forwarding tables of the devices that have been affected according to administrator instructions. However, let's imagine that we have a large-scale network where too many devices have been affected. So too many forwarding tables will have to be refilled. And of course, this is a time-consuming task. The other method that SDN has is protection. So how does it work? Protection is that the controller, at the moment of the initial setting up of the network, fills not only one forwarding table per device, but another one that has a backup path. Okay? But let's suppose that the network has suffered a big damage, like an invasive one, that has caused more than one device being failed. So it's possible that also the backup paths are no longer available. So that's a problem for the network operation. So we state that it's definitely needed a management system that provides an appropriate solution based on the analysis of the current network state, or maybe it can analyze also past states and give the appropriate solution, management solution for each situation or each network event. Also, recent authors, as you see here, has stated that SDN and NME share their objectives. That, well, you can read it. It's just like PIN4 self-adaptable management or self-management. Well, in the state of art, we have a list of quite recent works that have worked on the relation between SDN and ANM. So we have identified some common shortcomings of those related works. All of them ignore recent proposal of vertical management plane. So they still remind that putting management task at application plane, at control plane. They don't have a strong emphasis on intelligent algorithmic components, and up to us, analysis in systems need strong intelligent components. None of them have autonomicity at node level. This is being discussed. Me and my colleagues have been discussed whether or not SDN devices have to be autonomic. We're discussing, but up to now we are considering. And we are following recent reference models for autonomic network management that for us could be adapted to SDN conditions or SDN requirements. We have genetic autonomic network architecture from E2 and the group AFI, Autonomic Future Internet, and the ANIMA reference model from the IETF ANIMA working group. So we have a research question and a hypothesis, as you can read. How to efficiently manage an SDN with vertical management plane, being aware of change in network state with minute human intervention. So the hypothesis is layer decision elements in an SDN with vertical management plane supported on intelligent autonomic control loops could contribute to perform self-functionalities achieving efficient management. So I know the coming question is how can we test then that we achieve this? We still don't have the whole answer, but we have like expected contributions. We are filling this list. So maybe reducing configuration time will be a first measure that we have, because reconfiguration is one of the most common management tasks, you know. And we expect to achieve distributed management task within micro loops that they go on devices, and the normal loops, they have a slower reaction, they go in the management plane. So AutoSDN is our framework. By the moment, we have just a high-level overview. So we are aware we will need decision elements in the management plane. Of course, we will need a knowledge base. What we have here is needed information for the whole system, like the policies can be here, policies, any rules, all information about devices, capabilities of that stuff. For example, we can have a set of plans, action plans. All that stuff can be here. This is like a translation service. It's a translation service, so to translate requests and responses. Here, we have a representation model, can be Yang, for example. Resource representation model is required. And here we have the network elements, nodes or devices, with the micro loops that we are considering. Well, this is like to see the device with a zoom in. This is, I have to say, this is the proposal from GANA architecture from E2, okay? But our concern is how to achieve these layered decision elements, layered decision elements in an open flow based switch, for example. That's our current concern. So what we have under consideration by the moment is to follow recent reference models, to work with the vertical management plane, to work with the hierarchical architecture for decision elements in ACLs. I have here this because we are trying to understand very well how the relation between decision elements and autonomic control loops. For example, ANIMA talks about control loops, but decision elements also, but more focused on control loops. There's a draft about autonomic control loops, but E2 works more focused on decision elements. So I don't know still if a decision element is a component of the loop or they just have a kind of relation. We are working on that. We will consider a knowledge plane that some recent authors has stated. The knowledge train is to to have the information model and the data model that could be Yang from IETF. The information model, we know there's some discussion also about if both are important or just the data model. We are aware that exists an RFC from IETF, an old one that talks about this relation. And finally, we want to provide intelligent capabilities to network element, which is being kind of worked on in IDNet from IETF. Just to be defined, policy treatment, if we're going to use intents, super working group works on that also. How will be the communication between decision elements or an interloop communication? Maybe graphs, maybe we will use graphs. That is the protocol that Anima is working on. We will use priority of events. Reporting is also an important part of the loop. We're looking for a name. This is just the name for this presentation, but we're looking for an official name of the framework. So I have some references. Thank you. If questions, please slow spelling.
Thank you. Questions / feedback? I have one comment about the question that you raised, whether a network node would be autonomous or not. And I want to remember that the definition of an autonomous element may not be in a device. It could be something inside the device, could be the device itself, could be a bunch of devices, could be the SDN network itself. So it's something that is elastic.
If I can, Diego Lopez again. I will. Well, I guess that would be my accent. That would be not very difficult for you to understand me anyway. So, o puedo hablar en español, So no, it's a couple. It's something in addition to what Lisandro was saying. Precisely is that well, more than thinking in devices, I will start thinking about functions or services, and all of them have to be autonomic. In general, whether the individual device, the individual box is autonomic or not, is something that if things go as we expect them to go in the future, would be completely immaterial. I mean, it would be the same because the devices will be composed and the services will run, will overflow devices, or you will have several devices several services inside a device. So it will become a different dimension. It will be a physical dimension that will be not relevant for the services, ideally. This is one thing. The second thing is a recommendation. You mentioned Ghana and Anima. It's not because we are in the IETF. Use Anima. Just
Okay.
Ghana can be. I mean, Ghana is in my view something that is overly complicated, and it reflects very much an approach that is sort of. Let's say old-fashioned, I would say, or it's from the old times. This is something that made sense some time ago.
They have data versions from last year.
Oh, yeah, sure. Yeah, no, but, then we can talk about how things become, I don't know, you can have a repeated doing versions and things being even a little bit old-fashioned. My impression is that the Ghana precisely doesn't take into account well,
I got it.
This idea of the services and devices and this change.
Okay, thank you.
This is Jefferson Aubrey. Just to mention that right now, I think that your work can be more like something that can use tools from Anima because of the current charter of the working group. It's more like basic infrastructure stuff. But at some point in the future, maybe Anima can be more open to how can I say that, to how to define the autonomic way to perform things in the network or something like this. So maybe in the future, your work can be, can fit to Anima.
Okay. Thanks, Sergio. Thank you. Thanks. We need some additional minutes. Just let me try to report very briefly what we have in our last meeting in Lisbon during IM this year. In that meeting, we were discussing about topics that will be important in the context of the research group. And one of them was try to come up with some, let's say, clarifications about intent-based networking and policy-based network management. This is something that it's been around. We heard about it in coffee breaks, but I think there is no, let's say, more concrete document that tries to clarify these aspects in a more, let's say, didactic way. Alex was there in the meeting. Alex, would you like to say some words about it, and what's the status of that effort?
Well, there's not much status of that effort, although actually there are some slides and so forth on the topic. But yeah, the issue was basically there's a lot of talk about intent, and intent is basically the next big thing. At the same time, the question is, what is intent really, and particularly how does it differ actually from other efforts before it? Because there's also the term policy, there's also the term service models and so forth, and all of those things, actually, when you look at it closer, are actually fairly closely related, and really actually, and actually then also when you look at the even at the definition of intent, for instance, the thing that basically says intent is policy. So basically, if that is the case, one question is certainly, are they synonymous, or do we really mean different things by them? And it would be good actually to have a position, or to develop a position on that. Basically, so my opinion is actually that the way they are used today is pretty much interchangeably in many contexts. So really, basically, it's a newer term for an old concept. At the same time, I do think actually there is certainly an opportunity in having different terminology, and we should really actually work out basically the distinction basically between them, what we mean with one point. And policy could be related to, okay, you have for instance, just the event condition action type of paradigm that goes with policy to basically indicate that, versus intent perhaps being something higher level declarative where you don't know actually how this is achieved. So basically policy is more something that is programmed, even if declaratively, versus something that potentially emerges and so forth. But actually, regardless actually what the precise distinction is, it's probably good to develop some kind of position or guideline for that, or simply to say, okay, they are the same and we don't really care. So that's all. And the question was also if there's if there's interest in this, even as a question for this community.
Zaro Mashkano. I'm a little bit confused. Did you say that there is no work being done? Because in the IETF, there are actually a number of efforts on intent. In the NEMO effort, there is a draft in ANIMA. So maybe I misunderstood your statement.
No, yeah, sorry, but maybe I didn't say the proper words. I mean that there are relationships, as mentioned by Alex, that could be clarified in documents.
Okay, yeah. So yeah, there is some confusion, and maybe the Nmrg helping into
exactly, yeah,
kind of defining and maybe making some kind of taxonomy work could be useful.
Yeah, taxonomy was something that we have come up with, but was not to say that intent was not there. No, they are.
Jefferson Nobre. But just to mention that the drafting in ANIMA is more like, I don't know, how, it says something like intent is a high-level policy. So there's nothing more defined than that, So probably it's just it just takes the sideline. It's not a real definition of intent, or at least a taxonomy or something like this, which would be helpful.
Basically, my opinion is basically if the definition really is intent is a policy, then we should actually really talk about policy. I mean, I don't see a reason to talk about intent. So if intent is something that distinguishes intent, that is something that would be worthwhile actually fleshing out.
Well, the current definition, for example, as mentioned by Jefferson, it's that intent is a special case of a policy. Because it's a high-level one. So we can say that I'm talking about policies, so it means that I'm talking about every kind of policy. If we talk about intent, then we are talking about one specific kind of policy. But that's not clear in that sense.
Yeah. Beth Weiner, exactly. So intent is policy, but policy is not intent.
So I mentioned before, we have this discussion started in IM in Lisbon. The audience there was much smaller than this one, but we wanted to check whether, as a research group, we agree that this is something that we need to exploit in order to come up with a proper, not say definitions, but proper clarifications about these aspects about intent, policies, and other things that Alex mentioned too.
Yeah, basically, kind of like, I think one historical precedent, if you will, was, for instance, the confusion in the past concerning data models and information models. And so there was similar type of thing in the, what was it, in the early 2000s, something. Then basically the draft was very basically written to establish basically once and for all, articulate the distinction.
Mm-hmm.
And something like that would be, yeah.
Mm-hmm.
Yes.
Mm-hmm. So does someone think that we should not tackle that issue? My suggestion, because of we are a research group, is that we try to also move this discussion not only to the meetings that we have, but also to the mailing list. And although maybe a little chaotic in the beginning, I think it's interesting to collect the several different opinions, and then come up with the next meeting. In principle, will be in. Maybe we can organize something in CNSM, but probably the next one will be in IETF 100. So until there, we may use the mailing list to collect the feedback and try to come up with something. Another aspect, but I think Iman is not on remote site. But another aspect was that, considering that we have a more clear view about these issues, also they imply some research challenges that could be interesting to be listed as the outcome of this research group, so that we can say to people that, look, these are the challenges in terms of research that could be interesting to be addressed. So Iman was somehow the leader to come up with some initial work on this list of challenges. Okay. Anyone has any additional comments about these aspects? Okay, so thanks for coming. See you next time, and hope we can interact more in the mailing list. Now we have another excuse to do that. Ah, where's the